Welcome to David Alexander Maths Tuition. This is chapter 5e on solving trigonometric equations. So the good news is with this chapter, it shouldn't be anything that you haven't done already in year 12. You would have done some solving of trigonometric equations in year 12, but in degrees. This time we're just doing it in radians. The only difference is you need to make sure that your calculator is set to radians. So make sure it's set to radians. Okay, so for the first one, if the cos of x is 0.9, then that means x is going to be the inverse cos of 0.9. So shift cos 0.9, therefore x is 0.45 to 2. Oh, sorry, so it's three significant figures, so 0.451. So usually when we were working in degrees, you had your primary, and this is my primary solution, and the next one for cos was always 360 degrees minus the primary. And once you've got your sort of set of solutions, all we need to do after that is add 360 degrees. So all we need to do here, we're not in degrees, we are in radians. 360 degrees is 2 pi. So for my next solution, it's going to be 2 pi minus the 0.458. Instead of 360 degrees, take away the primary, it's going to be 2 pi, take away the primary. So on the calculator, it's just 2 pi minus the answer, and I'm getting 5.83. Now, if I wanted any more solutions, well, in fact, it's always a good idea to make sure, well, it depends how confident you are in maths, obviously. I know that these are all the solutions I need. However, it's a good idea sometimes, if you don't know what you're doing, is to find the first solution that falls outside of range. Now, the third solution is going to be the primary plus 360 degrees, but we're not in degrees, we are in radians, so we're going to be adding 2 pi. So my first solution was 0.451, and if I add 2 pi to that, I'm getting 6.73, and 6.73, that is greater than 2 pi. And if you're not sure, well, what is the value of 2 pi? 2 pi is 6.28, so 6.28 is less than 6.73, so this is out of range. So there's only two solutions, 0.451 and 5.83. Similarly, sine x equals negative 0.3, therefore x is the inverse sine of negative 0.3. So shift sine minus 0.3, and I'm getting my first solution, which is negative 0.305, three significant figures. Now that is no good because that is less than 0. Now my next solution, so with cos it was 2 pi, take away my primary. With sine is pi minus my primary. Even if the primary is negative, that still works. Pi take away answer. I'm getting 3.446, so three significant figures, 3.45. And my next solution is the first solution plus 2 pi. So if I just go back to the negative 0.305 and add 2 pi onto that, I'm getting 5.978, so 5.98. And if I want to see if there's another solution, so this solution we're discarding, and if I add 2 pi to 3.45, that takes me beyond 2 pi. So there's only two solutions, 3.45 and 5.98. So for tan, it's much easier. So therefore, sorry, what am I doing? X is the inverse tan of 20. So shift tan 20, I'm getting 1.52. And remember that with tan, it just repeats every 180 degrees. So remember that 180 degrees, that is pi radians. So all I'm doing is adding pi each time. So plus pi, that takes me to 4.66. And if I add another pi for my next solution, that will take me to 7.80. That takes me beyond 2 pi, well obviously because I've added 2 pi onto something that's greater than 0, so that is beyond the limit. So two solutions, 1.52 and 4.66. Okay, so similar type question. All we need to do here, if 3 sine x is 2, then sine x is 2 over 3. So x is the inverse sine of 2/3. So x is 2 divided by 3 equals shift sine answer equals 0.72. how many significant figures? So 9, 7, so that'd be 3, 0. And my next solution is going to be pi minus that, so pi minus answer, which is 2.411, so 2.41 to 3 significant figures. If I want to experiment with my next solution, I'm adding 2 pi onto this first solution. Well, if I add 2 pi onto something that's positive, that will definitely be greater than 2 pi, so I know that I'm done. Just 2 solutions here. Negative 4 cos x equals 0.1, divide by negative 4. So x is going to be the inverse cos of 0.1 over minus 4. So 0.1 divided by negative 4, shift cos answer equals, and I am getting 1.595, so 1.60. And my next solution is going to be 2 pi subtract 1.60, so 2 pi, take away answer, and I'm getting 4.69. Try writing a 6, not a 9, there we go, 4.69. My next solution will be 2 pi added on to 1.60. That will definitely be greater than 2 pi. So only 2 solutions, 1.60 and 4.69. Okay, with these ones here, again, this shouldn't be anything new. I'm just going to subtract 1 from both sides. So that becomes negative 3. Divide through by negative 4. So the cos of x is negative 3 over negative 4. In other words, the cos of x is 3/4. So x is the inverse cos of 3/4. So 3 divided by 4, shift cos answer equals 0.7227, so 0.723. And my next solution is going to be this primary subtracted from 2 pi. Remember, cos we subtract from 2 pi, sine we subtract from 1 pi, so x is 5.56. And if I add 2 pi onto my first solution, that will take me above 2 pi, so I know that that will be beyond the limit. Okay, this final example, I'm going to subtract root 7 from both sides, divide both sides by root 3. So therefore x is going to be the inverse tan of 6 take away root 7 over root 3. So 6 minus root 7 equals, divide by root 3 equals, this is how I type it into my calculator, you might do something different, shift tan answer equals, so my first solution is 1.09, and with tan, remember we're adding pi every time, so add pi onto that, so that's going to be 4.24. So that was plus 1 pi. If I add another pi, then I'm adding 2 pi to something that is positive, which would take me beyond that upper limit. So there's only 2 solutions, 1.09 and 4.23. Okay, so again, 3 significant figures. The only thing that is a bit of a problem here is the range was not a nice and easy 0 to 2 pi. So first of all, I'm going to subtract root 2 from both sides. I'm now going to divide by 5. So what we can say is that the cos of x is root 3 take away root 2 over 5. So therefore x is the inverse cos of that stuff. So root 3 take away root 2 divided by 5, shift cos answer equals 1.59. Sorry, I can't read, that's 5, sorry, not 5.9, 5.0, it is 5.07, so 1.51. My next solution is this subtracted from 2 pi, so 2 pi, take away the answer, which is 4.775, so 4.78. And we can see that this is greater than pi. Hopefully we know that pi is 3.141, so I'm going to exclude this one. Now, remember, we've got this pair of solutions. Now, if I was working up to the next one up, I would be adding 2 pi to 1.51. And for the fourth solution, I would be adding 2 pi to my 4.78. So if I want the one that is before 1.51, I'm going to subtract 2 pi from the 4.78. So take away 2 pi, that is negative 1.51. And if I want the next one down, then I'm going to be subtracting 2 pi from 1.51. So if I take away 2 pi from that, I'm getting one more solution, which is negative 4.775, so 4.78. And why are we getting these, well, they're not the same, obviously. One's positive, one's negative. Well, we do know that the cos of x does reflect in the y-axis. So that's why we're getting what looked like the same solution, but one positive, one negative. Okay, looking at the next example, I'm going to take away, so root 3 tan x is going to be 6, take away root 7, divide by root 3. So x is going to be the inverse tan of all that stuff. So 6 take away root 7 divided by root 3. Shift tan answer is 1.09. Okay, now remember that tan repeats every pi radians. So if I subtract pi from that, that would take me below 0. So there's no solutions beneath 1.09. But if I add pi to it, I'll get the next one, which is 4.23. And if I add pi again, 7.37. Sorry, 7.38. Actually, I'm not 100% convinced I got the rounding right for the 4.23. I might have just truncated it there. And let's work out the next one. Plus pi again, I'm getting 10.51. So 10.5 to 3 significant figures. Now, okay, well, what is the value of 3 pi? 3 pi is 9.42. So actually we can get rid of that last one. So there's only 3 solutions there: 1.09, 4.23 and 7.38. Okay, this final example, I'm going to take away 7. So 4 sine x is 3.2. So the sine of x is 3.2 over 4. So x is the inverse sine of 3.2 divided by 4. And what are we getting? We are getting 0.927. And my next solution is the primary subtracted from pi. So pi take away answer, 2.21. My next solution is that primary plus 2 pi. So 0.927 plus 2 pi, 7.21. And the one after that is 2 pi added on to the 2.21. 2.21 plus 2 pi is 8.49. Okay, now we are going up to 2 pi. Okay, so I'm pretty sure we've gone way too far there. And 2 pi is 6.28. So I can get rid of that. That was a waste of time. That was a waste of time as well. But what about the ones that are less than 0? So the one solution that is before the 0.927 is the 2.21 take away 2 pi. So the one before that, so is this one take away 2 pi, and the one before that will be 0.927 minus 2 pi. So let's work out the one that is before the 0.927. In other words, the 2.21 take away 2 pi, and that is negative 4.07. And the one before that is the 0.927 take away 2 pi, which is negative 5.356, so negative 5.36. Now we knew that the value of 2 pi was 6.28. So this is negative 6.28. Now, if we want to work out the one before, because we're not out of range yet, so what is the next one down? Well, it's going to be minus 4.07 minus 2 pi, and that will definitely take us beneath negative 6.28. So whatever that is, we can just get rid of it. So there's going to be 4 solutions: negative 5.36, negative 4.07, 0.927 and 2.21. Okay, so these ones are much harder, and the reason why is because we have a 2x and a 3x, not a single x. So this is where people can make mistakes. So to begin with, it's quite easy. If 7 cos 2x equals 5, then the cos of 2x is 5 over 7. So therefore 2x is the inverse cos of 5/7. So what we're doing is working out solutions for 2x. So therefore 2x equals 5 divided by 7, shift cos answer, 0.775. 2 pi take away that, which is 5.51. The next solution is 0.775 plus 2 pi, which is 7.06. And the next one is the 5.51 plus 2 pi, which is 11.8. So therefore my 1x solutions, because we are solving for x here, is all of these values halved. So now for half 11.8, that is definitely greater than pi, so forget that one. 7.06 halved is greater than pi as well, but 5.51 divided by 2 is 2.76, so that's definitely within range, and 0.775 halved is also within range, 0.388. Okay, so I have two solutions, but there might be more. So what I need to do is also, I've not considered the ones that are negative as well. So what I'm going to do, I'm not fiddling, I'm not adding or subtracting pi or 2 pi or anything here. Well, there are perhaps more advanced ways you can do it without doing what I'm about to show you, but the safest way is to go back to your 2x solutions. We've got the first two, but we've not considered the solutions that are before the 0.775. Now the first one that is before 0.775 is 5.51 take away 2 pi. 5.51 take away 2 pi is negative 0.773. The next one before that one is going to be 0. So if we have here, let me just make this really clear, 0.775, 5.51, the solution, so this solution here is 2 pi off 5.51. The next one down is 0.775 take away 2 pi, and that is negative 5.51. There we go. And the next one down is this one here, which is the negative 0.773 take away 2 pi. Well, that will definitely be less than negative. Actually, we shouldn't be even looking at that really. Let's take away 2 pi from minus 0.773, take away 2 pi, and that is negative 7.0. 2x is negative 7.06. So we can see that these are actually just the negative versions of these. So again, all I'm going to do is I want x solutions, not 2x solutions. So I'm going to divide all these by 2. So minus 0.773 divided by 2 is minus 0.387. And minus 5.51 divided by 2 is negative 2.76. And if I half minus 7.06, that is definitely going to be less than minus 3.14. So that one we can forget about. So we end up with 4 solutions for x. Remember, we're working out solutions for x, not for 2x. So for the second example, nice and easy to begin with, we're just going to divide by negative 3. So these are the solutions to 3x. So 3x is the inverse sine of root 2 divided by negative 3, shift sign, answer. So the first one is negative, so minus 0.49, 491 even. The next one, because this is sine, is going to be pi minus that answer. That's 3.63. And the next solutions are, well, the next pair of solutions is the first pair plus 2 pi. So minus 0.491 plus 2 pi is 5.79. The next one after that is 3.63 plus 2 pi, which is 9.91. The next one after that is 5.79 plus 2 pi, which is 12.1. And the next one after that is 9.91 plus 2 pi, which is 16.2. Now, I'm not sure if I've gone far enough or not. Let's see if I get one that comes, where it falls out of range, so one that is bigger than 3.14. So remember, all of these solutions were for 3x, so all I need to do is divide them all by 3. So minus 0.491 divided by 3, so the first solution so far is negative 0.163. The next one is 3.63 divided by 3, and that is 1.21. 5.79 divided by 3 is 1.93, so still easily within range. Next one, 9.91 divided by 3, which is 3.3. Now that is definitely greater than pi, so that is not a solution. So I can ignore the 12.1 and the 16.2 as well. So far I've got 3 solutions. but there might be more solutions lower than negative 0.163. Now, so it's the 3x ones I'm going to go back to. The solution that is before the negative 0.491 is the one above it, so minus 2 pi. So 3.63 take away 2 pi, and that is minus 2.65. And the one before that is negative 0.491 take away 2 pi, which is minus 6.77. And if I want one below that, let's work it out. Why not? Is negative 2.65 take away 2 pi, and that is minus 8.93. So these are all my solutions for 3x. So I know that I'm going to be dividing them all by 3. And I know that if I divide 8.93 by 3, that will definitely be less than 3.14. So that is still within range. So I'm going to do one more. Well, maybe I need to do more than one more, but I'm going to do one more for now. Let's do negative 6.77, take away 2 pi from that, and I'm getting negative 13.1. Okay, so I've got these new 3x solutions, which are negative 13.1, minus 8.93, minus 6.77, minus 2.65. So ideally, I want one to fall out of range. Just over here, I worked out that 9.91 gave me 3.3. On the top end, I've got one that's out of range. I need to find one the bottom range, on the bottom end, that is out of range as well. That way I know I've got them all. So if I divide this negative 13.1 by 3, I'm getting minus 4.3, which is less than negative pi. So that's not a solution. What about minus 8.99 divided by 3? That is giving me minus 3.00 if we're rounding to 3 significant figures. So that is within range. So negative 6.73 divided by 3 is minus 2.24, and negative 2.65 divided by 3 is minus 0.883. So there we have it. We have 6 solutions in ascending order: negative 3, negative 2.24, negative 0.883, negative 0.163, 1.21, and 1.93. Okay, so with these ones we're getting a little bit more advanced. 5 sine squared x equals 4. Well, we can simply say that the sine squared of x is 4/5, or 0.8. So if sine squared x is 0.8, remember sine squared x means the sine of x squared is 0.8. So therefore, the sine of x is the square root of 0.8. Now this is where some students might make a mistake. Remember, there is a plus and a minus root of 0.8. So first of all, I'm going to consider the positive root of 0.8, and root 0.8 is whatever. Shift sign that. I'm getting 1.107, so 1.11. And my next solution, because this is sine, is pi take away that, which is 2.03. Now I'm also going to do it again, but this time minus the square root of 0.8 and inverse sine that, and I'm getting negative 1.107. My next one is going to be pi minus that answer, which is 4.24. Now in this particular occasion, this one is too low, that's less than 0, so that's not valid, and 4.24 is greater than pi, so this one's not valid. So here we only have 2 solutions. Let's look at the next one. So what we're going to do here is I'm going to rewrite this as 5 tan squared x take away 2 tan x minus 3 equals 0. Okay, so what we've got here is a quadratic. So let's just pretend it was a, forget all the tans. Let's just see that as a 5x squared take away 2x take away 3 equals 0. But instead of solving for x, it's tan x equals some stuff and tan x equals some stuff. So go to the quadratic equation solver on your calculator, unless it's one that you can easily factorize and solve. So 5x squared take away 2x take away 3 and I'm getting tan x equals 1 and tan x equals minus 3/5. Okay, so if tan x equals 1, then x is the inverse tan of 1. So x is pi over 4. If I add pi onto that, that's going to be 5 pi over 4. And if I add another pi onto that, that will take me above 2 pi. Now, I reckon if I subtract pi from this, and I'll get a solution that is less than pi over 4. Well, I'll definitely get one that's less than pi over 4, but I reckon it will be greater than negative pi, and that is negative 3 pi over 4. So from the tan of x equals 1, I'm getting negative 3 pi over 4, pi over 4, and 5 pi over 4. They're all within range, and that's from the tan of x equaling 1. What about the tan of x equaling negative 3/5? So negative 3 divided by 5, shift tan answer. I'm getting x equals negative 0.54. Add pi to that one. X equals 2.60. And if I add pi again, that will take me to x equals 5.74. And if I add another pi, then that will definitely be greater than 2 pi. And if I take away a pi from this negative number, that will take me below negative pi. So there's 6 solutions. So we can, if you want, you can, it doesn't matter if you don't put them in order really, as long as you've got them all listed. But there we have it. So 3 from the tan of x equaling 1, and another 3 from the tan of x equaling negative 3/5. Okay, for this final example, we've got a sine squared and we've got a cos squared. So what do we do? Well, hopefully you know that you can turn sine squareds into cos squareds, or you can turn cos squareds into sine squareds. So it doesn't really matter what we do, but let's go for 5 sine squared x plus 3 lots of, instead of cos squared, let's turn that into 1 minus sine squared x, and that equals 2. So let's expand the brackets. 5 sine squared x plus 3 minus 3 sine squared x equals 2. So 5 sine squared, take 3 sine squared is 2 sine squared x, plus 3 equals 2. Take away 3, 2 sine squared x equals, why can't I do simple maths? That's negative 1. So sine squared x is minus 1/2. So therefore, what that means is the sine of x squared is negative 1/2. Actually, this is a really bad example because therefore the sine of x would be the square root of minus 1/2. We can't square root a negative, so therefore there would be no solutions. Let me pretend that I put that one in deliberately just to give you one to show that there were no solutions whatsoever. There we go. Okay, so what we're going to do with these examples here, on the first one, both of these are going to be quadratic equations, by the way. The first one, we've got a sine and a cos squared, but I can turn the cos squareds into sine squareds. So I've got an equation with sine squareds, sine x's, and then we're fine. So what I can say is that the sine of x, I'm going to change the 3 cos squared into 3 lots of 1 minus sine squared x and make that equal 1. So therefore the sine of x plus 3, take away 3 sine squared x equals 1. So therefore negative 3 sine squared x plus 1 sine x plus 2 equals 0. So I'm going to get sine x equals something and sine x equals something else, hopefully. So quadratic equation solver at the ready. Minus 3x squared plus 1x plus 2. And I'm getting x equals 1. So sine of x equals 1. And the sine of x equals negative 2/3. Okay, now for the sine of x equals 1, actually I can just do that off my sine graph. When are we getting 1? So we're interested at, so remember this is 2 pi here, so this is pi, and this will be negative pi. So when's it 1? At this point here, which is pi over 2. So from the sine of x equals 1, we get x equals pi over 2. Now for sine x equals negative 2/3, so minus 2 divided by 3, shift sign answer, I'm getting x equals negative 0.730, and x equals pi, take away that answer, so pi minus answer is 3.87. And well, we know that that is greater than pi, which is 3.14, so we can ignore that one. But is there one beneath the negative 0.730? Well, let's find out. The one that is before negative 0.730 is 2 pi subtracted from 3.87. So let's just work that out. 3.87 minus 2 pi, and that is minus 2.41. And that is definitely greater than negative pi. So we're getting from the sine of x equals 1, we get one solution, and from the sine of x equals negative 2/3, we are getting just two solutions, negative 2.41 and negative 0.730, and we are ignoring the 3.87 because that is greater than pi. Okay, so what we're going to do for this second example. So first of all, what I'm going to do is I'm going to subtract 2 cos squared x. So we're going to get 4 cos squared x equaling, and I'm going to add 3 sine squared x to both sides. So I've got 4 cos squared x equals 8 sine squared x. Now I hope you remember from back in year 12, whenever you've got equations with cos and sine, if you divide through by cos, you can turn things into tan. Now we can do a similar thing here, except we're going to divide both sides by a cos squared x. So what we'll end up with is 4 equals 8 tan squared x. So therefore 4 over 8 equals tan squared x. So therefore the tan of x is going to be the positive or the negative root of 4 over 8, or 1 over 2. Okay, so let's go with the plus, the positive root. So the square root of 0.5 is whatever. Inverse tan that answer, I'm getting 0.615 plus pi 3.76 plus pi 6.89. Now I have a feeling that that might be above our upper limit. What is the value of 2 pi? I'm not 100% sure, so I'll double check. It is 6.28, so yeah, that is definitely no good. But maybe there's one below 0.615. 0.615, take away a pi, and I'm getting minus, and also getting x is negative 0.253. And if I subtract another pi from that, that will definitely be less than negative 3.141. So from the tan of x equals the positive root of a half, I'm getting these three solutions. Now I need to work it out from the negative root of 1/2. So minus the square root of 0.5 equals whatever. Shift tan that answer. So I'm getting negative 0.615. I'm going to add pi onto that, 2.53. And I'm pretty sure if I add on a pi to that, that will be greater than 3.141, which it is. Maybe there is one beneath negative 0.615. No, there can't be, because if I subtract pi from a negative, then that will be, well, definitely be less than a negative pi. So there we have it. We have 5 solutions, and we could rewrite these in ascending order if we wanted to. Okay, so on to the last set of questions. So straight away what we can say is that x minus pi over 6 is the inverse cos of minus 0.5. Okay, so these are not solutions for x, but for x minus pi over 6. So inverse cos minus 0.5 equals 2/3 pi, so 2 pi over 3. My next solution is 2 pi, take away that primary answer, so 4 pi over 3. And what I'm going to do is I'm going to add 2 pi onto these. So 2 pi, that is, so just think about this. So 2 pi, sometimes, how many thirds is 2 pi? Well, that is 6 thirds. So I'm adding 6 thirds. So it's going to be 8 pi over 3, 10 pi over 3, adding 14 pi over 3. There we go. All right, so we also might want to, definitely since we are going to a lower limit of negative pi, if I subtract 6 pi over 3 from 4 pi over 3, I'm also getting x minus pi over 6 is minus 2 pi over 3, minus 4 pi over 3, minus 8 pi over 3, etc. Right, hopefully I'm already, some of these will push me out of range. So all I need to do now is to work out the values that are valid. So all of these ones are for x, take away pi over 6. So all I need to do is add pi over 6 to them. So let's start with a negative 2 pi over 3 minus 2 pi over 3, and I'm going to add the pi over 6 plus pi over 6, and I'm getting pi over 2, sorry, negative pi over 2. Let's do the negative 4 pi over 3 plus the pi over 6, and that is negative 7 pi over 6. Let's go the minus, okay, so actually let's just think about this logically. So we are going in descending order here, so eventually we'll find one that is less than negative pi, and I've already found one. Minus 7 pi over 6 pushes us out of that range. So there we go. So from we can ignore the minus 4 pi over 3 and the minus 8 pi over 3. The minus 2 pi over 3, when we add the pi over 6, gives us negative pi over 2, which is within range. So now all we need to do is the easier job of adding the pi over 6 to these positive values. So 2 pi over 3 plus that pi over 6 is 5 pi over 6. And 5 pi over 6 is definitely within range. What about 4 pi over 3? 4 pi over 3 plus pi over 6, that is 3 pi over 2. So that is 1.5 pi, which is greater than pi. So actually, we've worked out a lot of values for x minus pi over 6, which we didn't need to, but I'd rather do too many than not enough. So we're only getting two solutions, negative pi over 2 and 5 pi over 6. Okay, so here's another one. Again, this one's a little bit tricky because we've also got the 2x involved as well. So what we can say is that 2x plus 0.4 is the inverse sine of 0.75. So remember that this is 2x plus 0.4. So inverse sine 0.75 is 0.848. The next one is pi minus that, which is 2.29. The next one is 0.848 plus 2 pi, which is 7.13. And the next one is 2.29 plus 2 pi, which is 6.57. No, that can't be right, because that's less than, have I done something wrong there? 2.29 plus 2 pi, which is 8.5, so that's more like it. So 8.57. I'll do another one, which is 7.13 plus 2 pi, and that is 13.41. So what I need to do, so this is for 2x plus 0.4. So I'm going to have to subtract 0.4 and divide by 2. So I'm going to do that to the first one. So 0.848, take away 0.4, and then divide that answer by 2. I'm getting 0.224. Well, that's definitely within range. 2.29, take away 0.4, divide that by 2. I'm getting 0.945, also well within range. And 7.13, take away 0.4 and then divide that by 2. I'm getting 3.36, which is too high. So I might as well forget the 8.57 and the 13.41. Now maybe there are some ones that are less than 0. So if I've got my values as 0.848 and 2.29, then the ones before that will be, well, the first one beneath 0.848 is 2.29 take away 2 pi, which is minus 3.99. And the one before that is 0.848 take away 2 pi, which is minus 5.44. So remember that these values here are also the values for 2x plus 0.4. So I need to subtract 0.4 from these and then half them as well. And I am getting From the negative 5.44, I'm getting minus 2.92. And from the negative 3.99, what am I getting? Minus 3.99, take away 0.4, divide that by 2, I'm getting minus 2.20. So I've not found one yet that's dropped out of range. So what is the next one beneath negative 5.44? Well, that's going to be minus 3.99, take away 2 pi, which is, it's getting a little bit cluttered here, minus 10.27. And remember that that is also for 2x plus 0.4. So again, I'll take away 0.4 from that and divide by 2. And I'm getting negative 5.33. So x is minus 5.33. Well, that is less than negative pi, so that is out of range. So I found the first one that is outside of the lower end. So that means I know I've got all the solutions, which are these 4 here.